have this wonderful data set, the best you can get at the moment. Because of, I have to say that also, it's not now free to everybody. You have to engage. A lot of these data has been given under the commitment of the UNESCO Friend project, so you can engage in that project, but the data will not be freely available because the agencies have given them under certain conditions. So that again is something that we perhaps the water community could work towards a little bit more happens in the climate community, that they have a much longer tradition for sharing. But then what we did then with we liked to, based on this data set, it's been used for many purposes here with our group in Oslo, but one of the purposes was to look whether we could detect any changes in the observations, and if we do find such changes, and if they are regional patterns in the changes, do they coincide with the climate predictions? So do we find a drier south, or do we find a wetter north in the stream flow? And that is actually what we do find. So this is a paper that came out in Hess last year. We're looking at stream flow trend and changes across Europe, and the main conclusion is that we do find on the mean annual values are becoming wetter in the north and drier in the south. We then also looked at the low flows to see whether the mean annual 7-day low flow measure is what's happening to that. And in general, because you have so diverse hydrology across Europe, we have the snow regimes in Northern Europe and not so in Southern Europe. There's sort of very different climate that's controlling climate forcing in the different weather patterns in the different regions. So in those regions we do have summer minimum flow, where the lowest flow is found in summer. That's where you find a decline, a reduction in the low flows. But in those regions where there is a winter low, which would be some regions in Norway, where the winter low is because of the freezing temperature, there is then the opposite. There would be a higher because there's more melting, and so you can't just analyze one big region with the same tool. You have to be aware of the differences in climate. So and then we split up. We were interested also to see what's the main reason for the larger picture. You see that it's wetter in the north and drier in the south. So we did the same type of analysis on the monthly flows, looking at changes on January, mean February, to see at then the large-scale pattern there. And then you find really you can dig into and then looking for the causes of the changes in the mean. Whereas there's an overall wetting in January, or in the winter months, December, January, February, where it's more or less, if it's color blue, it's toward wetter condition in the annual monthly mean, and the red is towards drier, and the grayish is like no change. And you see as you go, it's like so it's wet, and then until March it starts becoming drier in the south, but then there's a marked shift from March to April, which is really something we like to dig into to find more. So this is work we started now to look at climate drivers, whether it's temperature or precipitation that's behind these large spatial patterns. And then it sort of stays red, meaning that in all these months, April, May, June, July and August, where it's peaks, that means that the highest number of stations here are a trend towards becoming drier, and then it clearly starts becoming wetter again in September or November. And this is not like, this is wetter than normal for that month. So there seems to be some temporal and regional clear patterns in the monthly regime.
That's observed 62 to
this
2004.
Is observed. So this is the truth. So this is what we then really interested in looking into why, because for instance the drying, what is the cause of the drying? There's one of the postdocs that's just stopped, but she will present this at EGU, looking at the reason for the changes as well, because the weather, the circulation system changes, or is it because the internal signature of that circulation system changes? And it seems to be a combination. So that's what we're working at now, and I think that's important in terms of what can you expect in the future. Because this major drought we had in Europe in 2003 with a large heat wave in Central Europe, that was sort of another weather that normally was further down in the Mediterranean that sort of shifted northwards, and it is in these transitional zones between major climate zones that you do expect the larger relative changes. So there are predictions that say that the type of weather you had in Central Europe in 2003 will happen much more frequently in the future.